Hello everyone, welcome back to my new series on computer vision. So today we are gonna create a program where you become invisible. Sounds like magic, right? Yes, that's the magic of computer vision. So let us see the demo on how it's gonna work. I hope you liked the demo and I'm pretty sure you're excited on how to create it. So let us begin. It'll be just like how Harry Potter just vanished with his cloak. So basically we are gonna use a technique called green screen which is used even in movies. So basically what we do is we try to find a particular color. Here we'll use red. So what will be happening is you'll have a red cloak with you, and whenever you find whenever the computer sees the red color, it's gonna do some magic, and then it'll become invisible. So you're gonna find a particular color and you create a mask of it, and then you're gonna make it invisible. So what do I mean by invisible and creating masks? Let us understand. So basically what we're gonna do is first we're gonna take an image without anyone in it, and then we're gonna enter in, and we'll have something like a cloak. Here I've taken a red cloak and I've just kept it in front of me. So basically what happens is the computer tries to identify the red colors that are available on the screen. So after it identifies them, it only makes the one that it is identified as red to be white color. So you can see that it becomes white, and the ones that are not red becomes black. So this itself is what is called mask. So you create a mask of red color. So you have the points that are red in color to be white and the other points to be black. So you know which region you need to mask and other regions which have to be the same as the original one. So this is how it will be. We're going to take the background, and then we're going to stream the images, and then we're going to identify the red color. We're going to create a mask. So what happens after we create a mask? So basically what we do is we're gonna apply this mask to the real original image of the background and the image now we captured from the webcam. So basically what happens is, what we're gonna do is we have this original image. What we want is the places where red color is there, we want it to be swapped with the background image to be there. So what we're gonna do is we're gonna apply this mask. So we want the points from the background that are for the red color. So we want this to be changed with this. So that's why we make this black, because we don't want this to be changed. This should be same as the one that we captured now. But then since you want to be invisible, this is the region that is there of the red color. So you want it to be interchanged with the background that's there. So that's why you add this to it, and then you get this color, you get this mask, and then when you add it to the image that is captured from webcam, you get this. You need to make sure that the regions that have the red color are black, because you don't want to see the original image of the red color, but you want it to be of the backgrounds. But other parts which are there, you don't want to interchange them because they are not required. And then now we are going to do the real magic. We are going to add these two images and combine them to make a final image, and here you have your magic. So this is how we are going to do it. And before you continue, we need to understand a concept called morphological transformation. So basically there are operations that are performed on images to modify pixels based on some algorithms. So there are two types of morphological transformation. One is dilation and one is erosion. So basically in erosion, what you do is you have a particular image, for example this. What happens is it takes all the boundaries and then removes the boundary pixels. So what happens when you remove all the boundary pixels, it becomes like this, because here you can see the last layer is removed, so it becomes a little thinner, and the very small pixels that are there that are white over here are totally removed, because they are just one pixel, so it doesn't make a difference to have them. So it becomes this. And then dilation is where you instead of removing, you actually add the pixels to the boundaries, so it becomes thicker. Now we are gonna use these two concepts for image transformation to make it invisible person, because if you have something's very small red pixel somewhere in your background, you don't want it. So basically what we do is, if you have something like noise like this over here, you erode it, so you get something like this. But then if you use this, your mask will have a problem, because the edges won't be seen in your real image, and your invisible person's last edge would be seen. That's why we are gonna again dilate it. But then when we dilate this image, what will happen is, you don't have these pixels to be seen, as they're not taken from, you're not dilating the original image but the one that was eroded. So you'll get the proper image like this, but you'll not have these noises that are there. So that's what we're gonna do. So from the demo, I hope that you understood what you're gonna create. So it will be like this. So if you have a red cloak in front of you, from the camera it will be become an invisible. So let us see how to do it. I hope they are very excited to create it. So let us begin. I've already created the code so that we can go quickly. So we need the CV2 library, and then we also need the time library. Basically we want to make sure that we pause the program so that the user can move out from the frame and we can capture the background. So we need the time library for that. And then we also need this library called numpy, because we need to create an array and tell the CV2 library to give us the mask. So we just need this. We can install this library by going to your terminal as usual, and then giving pip install numpy, and then clicking enter. It will work. So I have already installed, so I can continue. Now we need to get the webcam. So webcam cv2.video capture. Since we need it from webcam, we give 0, and then we can just tell the user that we're gonna take the image of the background in 5 seconds. So after that, we pause the program for 5 seconds so that the user can move out, and then we can capture the background image. We are gonna create a while loop to capture the background, because if any problem is there and the webcam didn't work, it might not properly give us the image. So that's why we'll create a while loop. When we get the image, we just break this loop, so we'll have a single image of the background. We got the background. Now the background is ready. You need to get the width and height of the camera, and then we'll if you want to save the video, you can also do that. Since I'm not just saving it, I'll just comment it. And then we start the while loop. As usual, we take the image from the camera. If we check if it's there. If the camera is not there, that is red is false, then we break the loop, because it's not available and we cannot do anything. And then now what we are going to do is we can save what we had captured. If you want, you can do it, or if you need not, you need not do it. After this, over here we convert the frame to HSV. Basically HSV is also something like BGR or RGB, but instead of red, green and blue, it maintains it in the form of hue, saturation and brightness. We convert it to HSV because it is easier for the computer to get the colors quickly than the RGB format. So we convert it to HSV and store it to this variable called HSV. So after that, we give the limits for the color. So basically we tell within this range, if the color is there, then we want it to be white. So basically over here you can see that the color is not constant. It's red, but then at some points it might be a little darker, at some points it's a little lighter. So that's why we create in this range, and then it is in terms of HSV. So that's why it's not like how you see it in RGB format. So you convert it to in terms of HSV, and you give the lower limit, and this is the upper limit. Now you need to get this mask that is there over here. So you say mask with red is equal to cv2.inRange. So basically we tell if it's in this range, you need to make this white, and if it's not in that range, you may need to make it black. You need to give the image. So basically we give HSV image, we give the lower limit, we give the upper limit. You can have different colors. Since I'm using red, I'm only giving the limits of red. If you're using some other color, you need to make sure that it is in the form of HSV, and then you need to give it over here. And then as we saw, you need to perform morphological transformation. So basically we convert this, we first erode it so that we remove any noise points that are there, and then since the last points are removed, we need to bring it back. So that's why we dilate it. So we say morphologic x, and then we give what we need to do, and then erode, dilate, and then we do this. Now we get mask red will be this. After this we need to get this and this. So here we say frame of where np.where mask red is 255, it's equal to 0. Basically it means that you have this frame. In that frame where it is white, so basically where it is white, we say np.where mask red is 255. So basically 255 represent white. So that's why we say where it is white, set it to be 0, because this red we do not want to be seen, but it should be replaced with this. So that's why we make it black. So that's why we set it to 0. Now we take the background. We cannot directly change the color of the background, because if we do so, in the next image when we do, it will be like that and it will cause problem. So that's why we take a copy of the background, and then we say background is equal to bg.copy. After taking the copy, we make this background, we find np.where mask red is 0. So basically these points where it is 0, we set it to 0, and we want only the points where this is white to be seen. So we get this image and this image. So background we changed. Now we need this final image. So what we do is cv2.add weighted. So basically add weighted takes in the two images which we are giving, frame and background. It also takes the weights 1 and 1. So basically what weights does this, we say how much of it we should have. So basically if we say 0.7, if we set this to be 0.7, 0.6, it will make this frame to be a little less visible. So that's why we don't want that to happen. We have to make it constantly properly seen. So that's why I say 1, and then this is alpha. Then we give the image of the second image, and then this weight also should be 1, or else it will be less brighter, and because of it you can't see it properly. So you make sure it is 1, and then the last is gamma. So basically it adds to it, and then it can make it a little darker. So you don't want it to be darker, so that's why you set it to 0. So what actually it does is it applies this formula to it. So it applies frame, it multiplies it with alpha. So basically alpha is 1 that we have entered over here, and then it adds the background. So you frame, it takes the frame 2, and then it multiplies it with beta, which is over here, which we gave, and then it adds a gamma to it. So this is the formula it actually applies. So basically what it does is it tells how much of it should be applied, and then it combines those two images and it applies a gamma to it, which is we have set it to 0, and then it gives the image. So this is a final image. So we need to show the final image. So we cv2.imShow. This is just the heading of the window, Invisible Man, and then final image that we're gonna see. And then we're gonna say if cv2. If the s is clicked, then we break this loop. And then if you are making the video, you can say that video that write the final image. If you're not, you can just comment it. And then we're gonna release the webcam. We will also release if we release the video if we are capturing it or we are recording it, and if we have, and we delete all the windows that being presented. So this is how it's gonna work. Let us run and check. So we first need to move out when we run it so that it can take the image of the background, and after it takes the image of the background we can use the cloak and move in. So it has taken the image of the background. Now let's see how it's gonna work. 3, 2, 1. Okay, yeah, it's working properly. You can see that it's making me invisible. It's able to identify the red color. So I hope that you loved it, and there's more coming in the future classes. So before you leave, let me tell you that what we did today is put up in GitHub. So if you have any doubt, you can come here, and I've provided the link in the description. You can click on class 2 invisible person. You will get the code of what we did today over here. If you have any doubt, you can check it over here, or you can even put it in the comment section. I'll answer as fast as possible. I hope that you loved this video and are excited about the next one. Let me tell you a fun fact. The same technique we used today is used in movies to shoot things and backgrounds that are not possible. So you just learned a very advanced concept that is used in movies. I hope you loved it. So thank you everyone. Please learn, like, subscribe and share, and click on the bell button to get my latest videos. Please subscribe because most of my users do not subscribe and just see the video. Thank you everyone.